Now children, in this video, we will see something very important, one very important concept which you need to know from now onwards. Now see children, when they ask you pH is equal to minus log to the base 10 H plus ion concentration expressed in moles per liter. Fine. Suppose it is an acid children. So total H plus ions will be 10 to the power minus log base 10 coming from water as well as coming from acid. You will say why so? Children, we have solution. Solution will have water as well as acid. So both are giving us H plus ions. Water also will give us H plus ions as well as acid will also give us H plus ions. So you will say from where you got these values? I will come to that point slightly later. Now see children, we know Kw. What is Kw? Ionic product of water. Ionic product of water is equal to H plus and OH minus ions present in water. We know the value of Kw under normal conditions is equal to 1 into 10 to the power minus 14, right? We all know it. We have done it previously. Now suppose H plus is X. So OH minus will also be X. So from here if you see 1 into 10 to the power minus 14 is equal to X square, right? From here. So X is equal to under root of this is equal to 1 into 10 to the power minus 7. From here you see children, thus water under normal conditions has this H plus and OH minus, this both X which has come here is equal to 1 into 10 to the power minus 7 moles per liter. So water under normal conditions has H plus equal to OH minus equal to 1 into 10 to the power minus 7 moles per liter. So here we have seen how water gives us H plus and OH minus value and how water gives us H plus and OH minus ions and what are their values. Both H plus and OH minus ions present in water have got to be same. We all know logic says H plus and OH minus, and after calculation we got the value for H plus as well as for OH minus equal to 1 into 10 to the power minus 7 moles per liter. Point clear. So this is what water will provide us H plus, OH minus, and the value is equal to this. For H plus and OH minus both equal to this value. This we will be using for calculating our pH as well as for pOH. And actually we should also incorporate these values while calculating pH or pOH. Now, go back to our any simple normal calculation of pH. Suppose children, prior to that, you see you were taught in lower class that pH of water is 7. Children, it has come from here. Minus log to the base 10 of 7 if we take pH. If you just calculate minus log base 10, 10 to the power minus 7, it will come out to be 7. So that is why we say pH of water is 7 as well as pOH of water is also 7 children. In case of water, pH is exactly equal to pOH is equal to 7. From where we got it? Simply minus log to the base 10 of H plus, pH will be 7, minus log to the base 10 of OH minus, pOH also will be 7. If you put it value, in your rough copy, you do it, you will get the same value. So in case of water, it's not only pH, but pOH is also 7. So from here only, children, then we used to have the formula pH plus pOH is equal to 14. It is like this here. Water has pH 7, pOH 7. You add it, total is equal to 14. So thus, pH plus pOH in case of water, pure water is 14 through this formula. Right? And when we put some acid or base into that, then pH and OH balance changes but always remains equal to 14. That also we had seen because for any solution, pH plus pOH remains equal to 14 Always. This is in water. They both are 7. So here it is this way. Otherwise, if suppose pH was 5, so 5 plus X is equal to 14. Accordingly, you can say it will be 9. pOH will be 9. And likewise, you have done question also based on that. Now children, we go back to calculation of pH. Suppose we are given an acid which is 0.001 m HCl, and they say calculate its pH. The point is pH is equal to minus log to the base 10. Here I did not say it is coming from water or acid. I just said total H plus in moles per liter, which is obviously something coming from water and something coming from acid. So water we have seen under normal conditions always gives us or will give us 1 into 10 to the power minus 7 moles per liter of H plus. So this we should use while calculating pH. Similarly, OH minus will also be same, that we should use while calculating pOH. So fine, we go back to pH here. So this we are getting from water and this we are getting from acid because this is HCl given to us as 1. Had it been H2SO4, mind you, then it was this into 2. Had it been H3PO4, it would have been this into 3. So whatever is there, you have to put from water and you put H plus coming from acid. I have put it here. Then I will go for calculation, children. Then what happens? You will say you never told us, you just said take this value. Children, actually this is the correct formula to be used for calculation of pH. But then we can see 10 to the power minus 7, which we are getting from water, is much lower than 10 to the power minus 4, which we get from acid. 1000 times lesser than what we are getting from acid, the H plus ion concentration. Hence, we can ignore this. And thus, for pH, I can only go with this, and towards end, I can say that pH is equal to minus log to the base 10 of this value only, and answer is 4. I can ignore this. Okay, just to make calculation easy. Fine. So this is what you have learned. You see, similarly here suppose calculate pH of 10 to the power minus 8 MSCl. I would have taken simply pH is equal to minus log to the base 10. 10 to the power minus 8, pH is 8. Now children, you go this way, but this is here absolutely wrong. Why? I will tell you. My actual concept is pH is equal to, this is totally wrong. I put cross here and totally wrong. pH is equal to minus log to the base 10 H plus ion concentration. Again like this, go this way. Coming from acid and coming from water. What you're getting from acid, what you're getting from water, put the value correctly. Now here, this M means this much H plus coming from acid and this much will always be coming from water. That is always there. No exception. Now, you will say here you asked us to ignore. Notice here children, here water is giving us more H plus than acid. Point to be noted. We are getting more H plus from water than from acid. So, which book, which teacher, which concept, which logic will say that you ignore this and you go with this? No way. Nobody can teach us. No logic says that you ignore this value and you calculate with this. Hence, we are bound to take into consideration the H plus coming from water, and which we can see clearly is much higher than what we are getting from acid. Water is providing us more H plus ions per liter than what acid is providing us. So we have to add up, incorporate, take into consideration both the values. This coming from water, this coming from acid. Now after this, chemistry is over. So this is there, this is there. Now your calculation. So children, you see, now after this step, children, after this step, chemistry is not there, it's you and your calculation. So to bring them in the same power level, I said 0.1 into 10 to the power minus 7, and this is 1 into 10 to the power minus 7. You simplify, you add up, it becomes 1 into 1.1 into 10 to the power minus 7. You calculate. Had it been just 1, answer would have been 7. Since it is 1.1 and here we have minus log, definitely I know value will be lower than 7, lesser than 7. So nearly 6.85 or 6.9 or 6.9 something, whatever. I took approximate value. I have not used calculator. You can use a calculator and you can go with that. So children, you have to see actual formula for pH calculation is minus log H plus ion concentration, where you should have all H plus which are present in the solution, and then you see can we ignore it or not. Frankly speaking, as much as possible we should not ignore. Say till this point we could ignore. Had it been 10 to the power minus 5, actually we should not ignore because there's not that much of difference. And once it is 10 to the power minus 6, we should never ignore that. But then children, this time presently you have calculators, you are provided log tables, etc. In olden times they were not there. So for the ages the trend has been used that fine, we can ignore and you can have the simple calculations. It is something like that, children. The value of your G in your physics, right? Acceleration due to gravity is actually 9.8 something, but we use sometimes 10. Even the books write, okay, you may use value of G as 10. We say 1 calorie is equal to 4.2 joules. It is not 4.2, it's 4.198 something. So children, likewise, we are using approximate values for simple calculations. Now, in present time, your calculation part has become very easy. You're using calculators, so you can go with that, right? But you should be confident and you should know very well the calculations of log, and I hope you have some idea, and if not, please take somebody's help and be thorough with simple calculations of log the way it is required here. So children, again I'm telling you the very logic. Firstly, when you say pH of water is 7, how it is 7? If you just say pH is equal to minus log H plus ion concentration. So it is 1 into 10 to the power minus 7, pH will be 7. pOH minus log OH minus ion concentration, which is again this value, it will be also 7. So in case of water, when we say pH of water is 7, pOH of water is 7, how it has come, that I have shown you. Then we know that pH plus pOH is equal to 14. It is this way. pH of water 7, pH of pOH 7. You add up, it becomes 14. It changes when we add some acid or base. So pH may change accordingly. pOH also changes, but its sum is always 14. That point is there. Then children, whenever you're calculating pH, please remember that we have to take total H plus present in the solution. We should always show like this. Then in the next step, if you wish, you can write here the H plus which we are getting from water can be ignored as compared to this. You write this step, make it very clear, and then you calculate with this, and towards end you can show pH as 4. You can show, it will be accepted. Till 6 we can accept. Till 5 we easily go. Till 6 I would say avoid. Do consider this because there's not much of difference. If it is minus 6 and it is minus 7, there's not much of difference. Avoid that. Rather, you go very precisely with the complete value and calculate. Till 5 we don't mind. But when 6, I would suggest you not to avoid, not to ignore this value and go and calculate. But then if you cannot, then you write in the next line here H plus being obtained from water can be ignored. You write that. So it's still okay. But again I'm saying once it is 10 to the power minus 6, avoid ignoring. You consider these H plus and then proceed and see your calculation. Now, go back to again this question. Again I'm explaining. Children, you see yourself. They said H plus pH of, calculate pH of 10 to the power minus 8 mScl. This was the question. If I go by simple formula, pH is equal to minus log, and H plus is this because this is the concentration of HCl. So pH should be 8. Just think, children, yourself. Can we have the pH of acid as 8? Is it possible? Is it correct? Does this answer sound correct? When pH of pure water is 7, how can an acid have pH 8? So you yourself get, what is this answer? How can it be possible? You get a shock. Acid having pH 8? How is that possible? Certainly, because you made the mistake. What mistake? Because the logic is pH is equal to minus log of H plus, where what I am getting from acid and what I am getting from water, they both should have been considered. We cannot ignore what we are getting from water. Reason? Water is providing us H plus more than what acid is providing us. So which logic says, which concept says that you ignore this? Under no condition we can ignore this H plus coming from water. No, not at all. Since we have to consider, we cannot ignore because this is much more than this. Hence, we have to incorporate both the values and then you have to calculate. Even in your competitions, children, this question is asked. Calculate pH of 10 to the power minus 8 HCl. And the very first option given in your multiple choice questions is pH 8. And students quickly answer 8. Just think, can acid have pH 8? No. So actually the mistake was they did not consider this H plus coming from water, which is the blunder. Should never be committed. Please focus on this point. So first, you always learn from this video and now onwards that when we have to calculate pH, I will write both the values of H plus. One coming from water and the other what I am getting from acid. And on the very same lines for calculation of POH also. Only difference will be there. Here it will be POH. This value will be same because water has same H plus and OH minus concentration, and that is 1 into 10 to the power minus 7. How it has come? It has come through ionic product of water, which has this value. You have seen this in the previous video also. So you write both, and then if you feel it can be ignored coming from water, you ignore. Go ahead and then proceed. So I am suggesting from my side till value of minus 5 you can ignore because this is lesser. But if it is minus 6, only my suggestion, my advice, don't ignore H plus coming from water. But if suppose you find calculation difficult, some bio students face this problem in calculations, then they can ignore that and they can proceed till minus 6. Okay? Or even it is 7, mind you, it is 7. So you will say pH of acid is 7? No, you cannot. So I said till minus 5 you can ignore. But minus 6 onwards, if you are getting H plus, please never ignore. This is what I can suggest. Choice is yours, right? And why is only when it is minus 8? Next time you can have calculate pH of 10 to the power minus 7 M acetic acid. So you will say minus 7, pH is 7, and your answer will be 7. The pH of acetic acid, is it possible? So children, as I am telling you again, beyond minus 6 till minus 5 you ignore. Okay, make it easy. But the moment you have minus 6, please avoid ignoring. And lower than minus 6, please never ignore. What you're getting H plus from acid or base for calculation of pH or POH respectively, please do consider, otherwise you're bound to go wrong. Your answer will be wrong. And do learn at home the calculation of this through log, right? You have scientific calculator, you can see the values there. So I repeat the question which was there, calculate pH of 10 to the power minus 8 MSCl. You see, I had to go this way, minus log H plus, which goes this way, this coming from acid, this coming from water. I have calculated and I got this. And remember, water always has H plus and OH minus ion concentration exactly same, which is equal to 1 into 10 to the power minus 7 moles per liter. So this value to be used for calculation of pH or pOH. When you write the formula H plus for pH and OH, do consider, and then you write if you feel it can be ignored. I leave it to you. But my suggestion, till -5, like in case of H plus, you can ignore. But if it is -6, avoid, and lower than that, -7 and all lower than that, please never ignore. Otherwise, your answer is bound to go wrong. You will definitely go wrong. So I hope I've explained enough. I have put these crosses because they were not a part of your solution of this question. That was only this much from here to here. This step starts from here, the formula, and ends here the answer. These were just the points which I had to elaborate and explain you for solving this question, which were not to be shown, but yes, to reach this question and understand this question, we had to see how H plus and OH minus in water are 1 into 10 to the power -7 moles per liter to be used for calculation of pH and pOH, and how the formula of pH should be extended, where I should add up from water as well as from acid. I took this example, suppose it is acid 0.001 m HCl. So this is from water, this is we are getting from acid. I have converted this way, and right, and then I have put a value. Suppose it was H2SO4, I would have taken this value into 2. Had it been H3PO4, actual H plus would have been this into 3. This point also I have explained to you. That's why I wrote here HCl. You know, for HCl it is into 1, which is understood. Had it been this M, H2SO4 would have been this into 2 and would have been here. Had it been H3PO4 would have been this into 3 and would have been there. So please, questions are not tough, children, but put values correctly and then only go for calculations. And again, judge yourself, should this be ignored or not? If not, please go ahead with the calculation. If you feel it can be ignored, then you write it can be ignored. As compared to this, it is very low, right? So for this video, I think I've explained enough, and do see this video again in the evening when you get time. This is perhaps the most important numerical of this chapter, although not tough, but logics and points, what all are required, are very much involved in this, and they will help you. Children, on the very same lines, you can calculate anytime pOH. And when they ask you for bases the pH, so you know pH plus pOH is equal to 14. You first calculate pOH, I told you for bases always, and then you can solve it this way. pH plus pOH is equal to 14. You will say from where it got. I gave the formula pH plus pOH is equal to 14. It came this way. And for water, it's not pH. Even the pOH of water is also 7. This way you add up, comes out with 14. When you put some acid or base, either pH changes or pOH changes accordingly. But sum of those will be equal to 14. Hence, if it is base, you calculated pOH, you can easily calculate pH. And for acids, we directly calculate pH. Okay? So for this video, we stop here. I hope it is clear to you.